Hey, this is Ryan again at PG Fuel Injection. In this video, I'm going to walk you through how we diagnose drivability issues and take all the guesswork out of fixing your diesel. This 2002 Chevy Duramax with the LB7 engine came to us for a low power concern while towing. The customer was looking for a second opinion. They had had their vehicle into another repair shop and were advised that their injectors were the root cause of the issue, even though they had been replaced 3 years prior. The first step was to hook up a scan tool and look for any trouble codes. Unfortunately, all the codes were cleared by the previous shop. So at this point, we had to drive the truck and verify the concern and identify what system is causing the fault. And as you can see here, the fuel system is having trouble matching the desired rail pressure. With the scan tool still hooked up, the injector balance rates were checked for any fuel delivery anomaly. In most cases, looking at the balance rates will not identify a low rail pressure issue, but in this case, the health of the injectors were in question and needed to be verified. But with that being said, all 8 injectors were well balanced and within spec. Now, this is a pretty common issue in this year of Duramax. Here is a list of some of the more common causes for low rail pressure. So the previous shop wasn't wrong. It could be from high injector return flow or even a leaking injector body, but it also could be from a fuel restriction, a faulty CP3 pump, a faulty fuel pressure regulator, a leaking pressure limiting valve, a faulty rail pressure sensor, a wiring issue to either the regulator or the sensor, but it also could be the wrong type of fuel, such as gasoline, or even air in the fuel system, or just an external leak. As you can see here, this is quite a list, and without diagnosing the vehicle properly, you can end up throwing a lot of parts at this problem without fixing it. Now back to the diagnosis, probably the most underutilized tool for diagnosing any fuel delivery issue on a diesel engine is a fuel pressure gauge. And in this case, with a Duramax, we are looking at the supply vacuum, but it is just as critical. Here we can test for any restrictions, but also for the operation of the CP3 gear pump. But once again, everything was within spec and not the cause of the low power concern. Next, a quick check for any air in the fuel system was performed. There were some micro bubbles present, but this amount of air would not cause any noticeable drivability issue. It was addressed by resealing the fuel filter head later on during the repair process. So continuing on, we took a fuel sample from the filter and measured the specific gravity of the fuel, as well as checking the diesel for any presence of gasoline or water, but neither were found. Next, the fuel pressure limiting valve was tested for any leakage. This valve should never open during normal operation of the fuel system. In this case, the valve showed no leaks and the diagnosis moved on to the injector return flow test. In this step, all 8 injectors are being measured at once, and knowing the specific gravity of the fuel, we are allowed a maximum of 40 milliliters total. But as you can see here, we are well below spec at 11 milliliters. So the injectors were definitely not the issue, and we just saved the customer from a costly and unnecessary repair. Now returning to the list of possibilities, the following have been eliminated: a fuel restriction, high injector return flow, the pressure limiting valve, any trouble codes that could indicate a wiring issue, and the presence of any gasoline or air in the fuel system. Finally, a visual inspection found no external leaks, but also any internal leaks by checking the engine oil level. The last 3 items on the list are the CP3 pump, the fuel pressure regulator, and the rail pressure sensor. All 3 of these components can be tested by using a digital oscilloscope connected to the rail pressure sensor. So with the scope hooked up to the rail pressure sensor, we have this screen here that shows the voltage on this axis and time down here in seconds. And this is our signal out of the sensor. We want about half a volt bias with the key on, engine off, and that's what we have here. So the next step, we're just to start up the truck, let it idle for a few seconds. And then with the scan tool, we can ramp up rail pressure to the maximum output of the engine. And it should be 160 megapascals in this case. You should be able to get that at idle. But I'm just going to head back here to the idle pressure where we can take a look at how smooth this is. There should be no surging going on with the rail pressure at idle. This is kind of the most common symptom of a sticking pressure regulator on these trucks. Usually you'll show up at idle, especially on a hot engine. As they get worse, you can start to feel it when you're driving, and the worst case scenario, you start to develop an actual stalling issue from the regulator itself. But in this case, things look pretty good. I can show you another capture here of a truck that actually had a problem. It has a pretty good wave going on as the PCM's fighting that sticking regulator to control rail pressure. But again, not in this case with this truck. So we've ruled out the regulator because even at the top end, it's pretty smooth there. Now, as you can see in this whole capture, we have no signal dropout. There's no flatlining of the sensor signal either. So the rail pressure sensor itself, it looks good. And if we change this over to pressure, we can actually read what pressure we're making. And like I said before, there's a 160 megapascal system. And we were maxing out just around 109. So the problem's occurring right now. And again, that's a good test because we can see that there's no surge going on or any dropout. So we're pretty much coming to the end of the diagnostic procedure. It's looking like it's the pump through process of elimination, but we really got to take things one step further. We don't want to just guess at what's wrong with this truck. We want to actually have proof of what's going on. So if we zoom in on this signal, we can get some further detail. This is a CP3 pump in this Duramax, and as the name implies, it has 3 pumping plungers. And a little bit different on these trucks, this fuel system. The CP3 pump actually rotates once for every revolution of the crankshaft, opposed to older injection pumps, which a lot of them were moving at half crankshaft speed. But here, what we're looking for is to see each one of those pumping plungers contributing to the rail pressure. So we line up our rulers with 2 peaks, and we can see the engine RPM here. It's right at idle RPM, which it should be. And if we pull out some degree rulers and line them up again between the 2 peaks, we have these zones here that are about 120 degrees, and each one should show an increase in pressure from one of the pumping plungers. But as you can see here, we have a pressure drop followed by another pressure drop and only one pressure gain. So what this is telling us is that we only have one functioning pumping plunger out of 3. We're down 66% of the output of this high pressure pump. And this is the evidence we are looking for to prove 100% that the pump is the problem with the truck. So I hope the takeaway from this video is how a professional shop can quickly and efficiently diagnose your diesel truck without changing any parts. This whole procedure takes generally less than 2 hours. And as you can see here, all the data we've collected, there's no guesswork. We know exactly where the problem is, and the pump is going to be the fix for the low rail pressure on this truck. But if you're having any issues with your diesel truck, think about giving us a call and we can book you an appointment. Thanks for watching.